Okay, so we're going to go same type of example. We're going to find the inverse of the function, graph the function and its inverse. And what I want to talk about is how I know that I need to complete the square. We had an example where we had x squared minus 2. There is one written x. This one, we have two written x's. This right here tells me we're going to complete the square. Okay, so I have two different variables. If I only had the one variable, which I have right here, then that means I'm going to go ahead and not have to worry about completing the square. I can just solve because I got a square all by itself. This one right here, I got a square and I got another x. That's not going to work out nice if I try to take the square root of the whole thing. Okay, so we're going to go ahead and I'm going to clean this up a little bit. So I'm going to erase. Let's see if, yeah. Give me one moment here. Okay, so that's how we can tell whether we're going to complete the square or not. Okay, so now I'm going to hold off on the graphing real quick. I'm going to go ahead and do what we need to do here with completing the square. So the first step in completing the square is we're going to remember we're going to move the constant over to the other side. So the first thing that we're going to do is subtract 8 from both sides. Okay, so I'm going to subtract 8. Okay, and now I got this term here. Now I'm going to go ahead and take that middle term divided by 2 and square it. Okay, so I've added the middle term divided by 2 to both sides. So negative 6 divided by 2 is negative 3. Squared is 9. So I'm adding a 9 to both sides. So I'm going to get y plus 1 is equal to x squared minus 6x plus 9. And then this guy right here is going to equal my two factors, which is going to be x minus 3, x minus 3. So I factor it. A little bit of a trick. Just jump to the point that you know it's going to be the same factor twice. So just jump to the step that I just wrote. The y plus 1 is equal to x minus 3 quantity squared. And then now I'm going to go ahead and I'm going to switch both my terms. So I'm going to switch my x and my y's. And I'm going to go ahead and just solve for y. So notice that the x and the y are being switched. Okay, so they switch spots. And now I'm going to go ahead and solve. So I am going to go ahead and take the square root of both sides. And when I take the square root, I put in a plus or minus, x plus 1. Got the y minus 3, and then I need to add 3 to both sides. And I have just now found the equation for the inverse of the parabola. Okay, so now we're going to talk about the graph. And it should be pretty consistent for each of these problems that we've talked about. I'm going to take the x squared minus 6x minus 8. I'm going to factor it real quick. It's negative 4, negative 2, so my zeros are 4 and 2. And I also know that my y-intercept, by looking at the standard format, is equal to 8. So I'm looking up here at this guy. I just factored it real quick. I'm going to go ahead and plot my zeros. So I got a 0 at 4. And I got a 0 at 2. And I got a y-intercept at 8. Opens up. I don't know how, and this is just a generic graph. You could use your graphing calculator. But remember, what we did here is we know we have the points 4, 0, and 2, 0. and 8, 0. So I can just flip all of those, and that's going to give me my new graph. So instead of 4, 0, we got 0, 4. Instead of 2, 0, we got 0, 2. And then instead of, and I'm going to go ahead and cancel this guy. I know most of you are probably saying Mr. Thornley made a mistake. It's 0, 8. So in the inverse one, it's going to be 8, 0. So now I go ahead and plot 8, 0, and that gives me the general shape of our inverse. Both are going in a positive direction, so the black one, the parabola, went in a upward direction because it's positive leading coefficient. So that means our inverse one is going to curve, or I should say open to the right. And so this is an extra example on working with finding the inverse of a quadratic. The inverse turns into a radical function.